Okay. This problem's already worked out for me here, so I'll just show you how to follow along. You may need to pause it if that makes you happier. A is going to travel in to B. A is the only one moving initially. B and C are just sitting on a frictionless surface. So A comes along and hits B, and they're going to collide elastically. So since they're colliding elastically, then we're going to use the elastic formulas that are given to us. So V1 prime is going to be the speed of A afterwards. V2 prime, of course, is going to be the speed of B after the collision. So I only used the front half of the elastic equations because B wasn't moving initially, and so the second half drops off in that situation. So if you check your numbers carefully, these are the numbers that were given. So this was M1, this was M2, and this was V1. And so you just start plugging in exactly like they're saying, and we find that A1 is traveling at a negative 1.19 meters per second. The negative, of course, implies that it's going backward. Now, when a smaller mass hits a bigger stationary mass, the smaller mass will always bounce backwards. So that's a good thing that we got a number like that. We should always get a number that reflects it going backwards in a situation like that. So then when we do the second equation, we find that B is now going 3.13 meters per second towards C. So if it's going towards C, C is again stationary. So now only B is traveling at this speed. So only B has momentum to begin with. So this is the momentum before the equation, and then this is going to be the momentum after the equation. So we have the combined mass here because B and C are going to stick together. So when B and C stick together, again, now I bring this mass over and I have the combined mass underneath it. And then when I solve for V, I end up finding that when B and C are now collided and stuck together, they are now traveling at 1.63 meters per second. So now B and C are stuck together and they're traveling across an area that does have friction. So when it does have friction here, now we want to know how far is it going to slide. Well, it starts sliding at 1.63 meters per second, and of course it's going to stop sliding when it goes at 0. So to find the D, the best equation to use is the Vf squared minus Vi squared over 2A equation. But again, if friction is my only force, then the A is just going to equal mu G. So I can take that A out and sub in mu G. So the Vf squared, of course, is going to be 0. The Vi squared is going to be what we initially figured out B and C together are going at. And then we divide by 2 and mu and G, and we get 48.483 meters, which is the same thing as saying 48.3 centimeters if you prefer to write it in the centimeters. So that's how you figure it out. You may need to pause that if you want to write down some stuff and get it copied. Hopefully that makes sense to you, what we did there.